Beyond smart cities, how grid, edge, fog, and cloud computing shape different industries. Introduction: Unlocking hidden digital power. When we think of modern technology, most imagine smart cities, but grid, edge, fog, and cloud computing are quietly transforming many industries far beyond city streets. Today, let's explore how each of these technologies works, where they are applied, and what kinds of tasks they handle, without mentioning smart cities. Grid computing, powering research and exploration. Grid computing links multiple computers into a shared network, working together to tackle massive problems. Where is it used? In scientific research, pharmaceutical development, and space exploration. What work is conducted? Complex simulations, DNA sequencing, climate modeling, and astronomical data analysis. Institutions like CERN and NASA use grid computing to solve problems that would overwhelm even the most powerful standalone machines. Cloud computing, backbone of global business and education. Cloud computing offers on-demand access to computing power, storage, and services through large, centralized servers. Where is it used? In education, finance, healthcare, entertainment, and logistics. What work is conducted? Managing patient records securely, running global banking systems, hosting virtual classrooms, streaming entertainment, and powering e-commerce platforms. Companies like Amazon, Netflix, and online universities rely on the cloud for scalability, reliability, and global reach. Edge computing, instant decisions at the source. Edge computing processes data closer to the source of generation, meaning faster response and reduced internet dependence. Where is it used? In healthcare devices, agriculture, autonomous vehicles, and industrial automation. What work is conducted? In healthcare, real-time monitoring of patient vitals using wearables. In farming, smart tractors optimizing fertilizer use instantly. In factories, predictive maintenance on robotic arms without waiting for cloud processing. Edge ensures speed, security, and autonomy where milliseconds matter. Fog computing, intelligent middle layer for critical systems. Fog computing acts as a bridge between the edge and the cloud, processing intermediate data to reduce bottlenecks. Where is it used? In autonomous transportation, industrial plants, and healthcare monitoring systems. What work is conducted? In autonomous transport, managing vehicle-to-vehicle communication. In factories, managing huge streams of sensor data before sending summaries to the cloud. In remote healthcare, managing data between local hospitals and major cloud systems. Fog provides a critical balance of latency, bandwidth, and intelligence. Key differences in how they operate. To summarize, grid connects separate computers to solve massive problems collectively. Cloud provides scalable global resources on demand. Edge handles urgent processing close to the device. Fog sits between edge and cloud, intelligently filtering and pre-processing information. Each technology targets a different latency, scale, and location challenge, complementing, not replacing, one another. Conclusion: future without limits. Grid, cloud, edge, and fog computing are driving innovation far beyond urban landscapes. From growing smarter crops to curing diseases faster and even exploring other planets, these technologies shape the future of every major industry, quietly working behind the scenes.